Hello everyone, my name is Chen Antai. I'm going to present a spectrally dense encoding method for designing a high-speed Ssvep PCI with 120 stimuli. This research involved Chinese Academy of Medical Science and Beijing Union Medical College, Tsinghua University, and Institute of Semiconductors. First, introduce the research background. Steady-state visual evoked potential SSVEP is a time-locked brain signal that follows the flicker or light. With joint frequent phase modulation, JFPM, we give each flicker a different frequency and phase, so the brain response can be separately more easily. In ITR formula, N means the number of stimuli, P is accuracy, and T is the total time for selecting a target and shifting gaze. Most study tries to make SVEP faster by reducing the selecting time and more accurate. But if using too many stimuli, it's hard to keep both high accuracy and speed. And whether JFPM works well when the stimuli go over 100 is still unexplored. For the proposed method, first, researchers design an SSVEP PCI speller with 120 stimuli, arranging in a 6x20 matrix, encoded using spectrally dense JFPM. In the formula, I is the row index and J is the color index of the stimuli. Second, target recognition employs SOTA TRCA, and optimal parameters from offline were applied in online experiments. As shown in the figure, due to harmonics, smaller spectral dense intervals and higher frequency enable more stimuli. For the experiment setup, a total of 18 subjects took part in 2 experiments, with some joint balls. In the frequency band, delta phase, number of subbands, and TS were predefined. In the experimental block, offline experiments use 6 blocks for system optimization, and online experiments use 7 training blocks and 2 testing blocks. For the evaluation metrics, performance was evaluated using accuracy, ITR, R-square, and signal-to-noise ratio. For statistical analysis, repeated measure, analysis of variance, and Bonfiloni-corrected post-hoc test was conducted in SPSS. In the offline experiments, the best accuracy was attempted with an SB equal to 4. And the highest ITR across data lengths was achieved with TS on 0.7 seconds. The analysis shows that NSB and TS exhibit an interaction effect, also indicate that NSB has a significant effect on recognition accuracy. For the different channels and blocks, results also show statistically significant difference in accuracy and ITR. The online result shows well performance which get 92 mean accuracy and 230 mean ITR. In the confusion matrix, you can see a clear diagonal which corresponding to the high accuracy results. On the right side figure shows consistency on the accuracy and R-square results. And the figures below illustrate a decrease in SNR with increasing stimuli frequency corresponding to a higher error rate on the right side region. For the last, conclude this research in 3 contributions. First, this study proposed SJFPM for 120 target high-speed SSVEP PCI. Second, test with 18 subjects shows high performance. And third, the approach enables new applications such as fast Chinese input and spatial navigation. That's my whole presentation. Thanks for listening.